Thank you for joining us today and welcome to our first Univix training video. We would like to discuss determining usable energy storage of a battery. This is very important when determining which battery you want to buy and how many batteries you need to buy for your system. First thing we're going to talk about is the typical drawdown of each different type of battery. Lead acid batteries are about 30%. AGM and gel batteries, which are sealed batteries, are about 50%. Carbon AGM batteries, which are our battery that we carry, are 90%, and LiFePO4 lithiums are 90% as well. So that is the maximum you can draw down that battery without damage to the battery. Obviously, carbon and lithium are the top two to be looking at. And this is incredibly important when you're trying to determine which type of battery you want to buy. You need to look at how many different batteries you would have to buy to make the same storage. We're going to use a capacity example of 200 ampere hours just to make the math simple. So that puts our lead acid battery at 30% capacity of only 60 ampere hours. That puts our AGM and gel battery at 100 ampere hours, our carbon AGM at 180 ampere hours, and our lithium LiFePO4 at 180 ampere hours. So that means if you wanted to do a direct comparison cost-wise between a carbon or a lithium and a lead acid battery, you would have to buy 3 lead acid batteries for every carbon or lithium battery in order to have the same capacity in your system. Now, another important thing is how we got to the rated capacity of the battery. Not all batteries are rated the same. They're not all created equal, and there's no governing body that says exactly how you have to rate a battery, so manufacturers shouldn't rate the battery any way they would like to. There is an international standard called the ISO standard for batteries, and that's 10 hours. But there's nothing that says you have to put that number on your battery. So lead acid batteries, like you would buy just a deep cycle marine battery in a store, those are typically rated at a 20 or a 24-hour rate. An AGM battery can be a 10 or a 20-hour rate. Carbon can be a 10 or a 20-hour rate. And lithium is typically either a 20 or a 24-hour rate. So now you see where the problem lies in. If they're not all rated the same, it's hard to determine what your rated capacity is to start with, because to compare different types of batteries, you have to use the same standard. So the best thing to do is to try to get the actual rating for each battery you're looking at on the international standard, which is the 10-hour rate. That is the most common standard for solar and energy storage batteries, and that's the standard everybody should be using, but they don't. On the spec sheet from the manufacturer, you can typically find that information under rated capacity, and they'll usually have a listing of different rates. You can see on our spec sheet here, we have a 10-hour rate, we actually have a 3-hour rate, and a 1-hour rate. Now, using our battery as an example, we're going to convert the usable energy into, what does that translate into kilowatt hours? Because everything is rated in kilowatt hours these days. So our 250 ampere hour battery, which is at a 10-hour rate, is actually 250 ampere hours. Because it's drainable to 90%, that gives us a capacity of 225 ampere hours. If we were to rate our battery at 20 hours, it's 302 ampere hours, and 24 hours is 317 ampere hours. So you can see as we increase the hour rating, it makes the battery look a lot better. But in conventional usage, you're going to be around the 10-hour rate. To convert that to kilowatt hours, it's a very simple formula. You take kilowatt hours as ampere hours divided by the voltage. So to get our usable energy, if we take our 225 ampere hours, we divide it by the nominal voltage of the battery, which is 12 volts, and we get 18.75 kilowatt hours. And I put the corresponding kilowatt hours to these various different ratings for the full rating of the battery as well. Thank you. We hope this helps you in determining what is the best battery for you. For more information, visit univix.com.